Okay, in this question they said they have a flagpole and it's creating an obtuse angle with the ground. So I've drawn a line here. Let's assume this green highlighted line is the ground, right? Ground is usually horizontal. And our flagpole is, I guess, leaning if it's making an obtuse angle, right? Otherwise it'd be straight up and down. So let's assume this is our flagpole. It's a bit of a leaning flagpole, okay? It says that the flagpole itself is 5 meters long in the question. And then it says that if the distance from the tip of the flagpole to the ground is 3.4, okay, let's lean this a little more because that's not realistically 3.4. 3.4 means this pole's probably, oops, I can turn this, I'm pretty sure. Yeah, there you go. This pole's probably is something a little more like that. Okay, so it's really on an angle, this flagpole. 5 meters long. And the distance from the tip to the ground, they said, was 3.4 meters. So 3.4 meters to the ground. They want to know the angle of the obtuse. Okay, flagpole makes with the obtuse angle it makes. Well, we create a right angle triangle in order to solve this, right? What we can do simply is the angle that would be opposite, because these would be supplementary angles. Okay, altogether they're going to make 180. We're going to look for this angle here. Do you remember your SOHCAHTOA?
Yeah.
Okay, so if I have, what side of the triangle is this considered to our angle x? This 3.4. Is this the adjacent, the hypotenuse, or the opposite?
The opposite.
Okay, so we have the opposite, and we have, what's this considered?
Hypotenuse.
So which of the rules would we use to solve this x? Opposite and hypotenuse.
Sine.
That's right. So we have sine x is equal to the opposite, which is 3.4, divided by the hypotenuse, which is 5, right? Technically, we bring sine to the other side. We have sine inverse of 3.4 divided by 5. Okay? So let's bring a calculator up here. 3.4 divided by 5, sine inverse 42.84. Okay? X is equal to 42.84. Okay, well, we have that. Essentially what that means is this angle X is 42.84. Now, we can convert to radians now. And let's actually talk about radians while we're at this. Let's create a little circle here. Do it in blue. Okay. So let's talk about radians, and we'll tip it out at the flagpole. Okay. If we were to start from here, and we were to rotate up to this part here, how much of a rotation in radians would that be? Do you know what that is? Technically, it's a 90-degree rotation.
Yeah.
So what is that in radians? Do you know?
Pi? 2 pi?
2 pi is in complete all the way around, right? Because that's what the circumference of a circle is. Okay.
Pi is 180.
Yes, that's right. So pi would be 180. 180 would be a flat line. So this was pi. How far would that be in reference to pi? That would be half of it. So what would we consider this?
30?
Well, as a
Pi over 2.
just pi over 2. It's half of pi, right? So that's what this redshirt is. So we know that our obtuse angle is going to be between pi over 2 and pi, whatever it is, okay? Now we can convert this to a radian if we like, and then subtract it from pi, okay? Or we can try to find out the exact degree of this and subtract from pi. Let's do it the other way. Let's find out this as a radian, this 42.8. So we know from our formula up in the top right, we had radians were equal to our degrees, which were 42.84, times pi, divided by 180, okay? So what that means, and actually I think, I wonder if I could do this. I could have technically put that into radians and solved it that way. But that's fine. Let's do our conversion. So this times pi equals divided by 180. 0.747, we'll say radians. Okay, so this radian is 0.747. Now, they may have liked this as a fraction, something like that. let's think of it like what we were talking about before, where we have to take our pi and we have to subtract this amount we just found. Okay? Now, technically, that's 1 pi. Okay? Even though there's no number there, we're doing 1 pi subtract 0.747. That seems like a bit much. I wonder if that has been reversed from what we've done. That seems like a bit much for this angle. Let's try that one more time. It was 42.84. We're just going to double check this. Times pi. Divide. No, it looks like it's going to be that. 180. Let's think of the cast system. I think we may have made an error here. Let's go back. Cast. So we have our C, A, S, T. Okay. We use sine, so sine should be a positive answer in that quadrant. So actually we should be fine with 42.84. I just feel like that's going to be a very large amount. So to double check, the reason I feel like that's a large amount is in degrees, this is technically 180. Okay. So on the side, this should also say 180 degrees subtract 42.84. Okay, and then we should be able to convert our answers and get pretty much the same thing. So let's see if there's a bit of a discrepancy here, because I feel like our radians may be off a little. Let's do it in degrees. It's always good to make sure our answers are logical. 42.84. So this is our degree answer. The obtuse angle should be 137.16. Is that number look familiar to you at all? 137 point, what did we say, 26? 16? 16. Oh. We're both wrong. 16, okay. If you recall, when we did the 42.84 times pi, oh, okay, it was similar to that. Now, this radian doesn't look like it's going to be exact, because what's going to happen when we subtract these radians? Oh, you know why? I know why. This is what we're supposed to do. It shouldn't be that. What we're supposed to do is actually, in radians, our answer is supposed to keep the pi. So we're just supposed to reduce this fraction. I'm not sure why I decided to equate the whole thing. Our answer is supposed to be in pi, right? That's why this is off. Because that number is 3.4. I'm not sure how well that slipped my mind, but so let's do 42.84 divided by 180 and then times pi. Okay. So we reduce the fraction first. Some silly mistake. 42.84 divide 180. Okay. What this is going to be is 0.238 pi. That makes much more sense. 0.2.
Wait, before did you do 3.1? That's fine.
What's that?
What did you do?
Before I did the multiplication on top, so I got a full answer. Oh. For instance, 1 pi is technically 3.14, right? So then in that case, 0.7 something would have made sense in terms of subtracting it. I was wondering why that answer was so wrong. Sorry, it's been a while since we did this. So now when we subtract, this is much more logical. We do 1 pi subtract 0.238 pi, okay? And what that's going to be is 1 subtract that. So 1 subtract 0.238. It's going to give 0.762 pi. 762 pi, okay? And then this would be the degree of that in terms of degrees. That's what our answer should be. Pi. That's what we got. Okay, so there's our radian and our degree answer. Okay, sorry about that mistake. That's good. It helped us think logically and show it in degrees anyway, so it worked out okay.